We continue learning workbook page 177. We're now going to solve a second problem involving transformations of exponential function graphs. Here's the problem. Below is the graph of y equals 3 to the x power. Translate it to create the graph of y equals 3 to the x minus 1 power plus 4. Okay, we're going to use the same approach we did in the previous problem. This is our parent function, y equals 3 to the x power. This is our transformed function. This is our flashcard. This is the new thing that we have to create. Now, the exponential function was not one of our flashcards from back in section 2.6, but we have enough information to create the points. Let's do the easy values first, then search for a pattern. For example, if x is 0, what happens when you put a 0 right here? You get 3 to the 0 power, which is 1. If x is 1, you get 3 to the first power, which is 3. And if x is 2, you get 3 to the second power, which is 9. So the obvious pattern here is times 3 times 3. What would happen if we went up the chart? Well, it would change to divide by 3, divide by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. And 1/3 divided by 3 is 1/9. We can very quickly and easily create the graph from this XY table of points. So, here are the values associated with the graph y equals 3 to the x power. We've got the graph in green and its asymptote in red. Okay, now we're ready to create the graph of our transformed function. We have to identify what changed and how. So let's compare our two equations. What changed? Well, next to this x, there's a subtract 1. So this represents a horizontal something, because the change is inside close to x. Because you're adding or subtracting, that makes it a shift. Horizontals are the reverse of what you would expect, so minus is actually moving to the right 1 space. Okay, the other observed change is this plus 4. That plus 4 is outside far from x, which makes it a vertical something. The fact that it's adding or subtracting makes it a shift. And vertical behaves the way you would expect. Adding is up, so this is up 4. So if we want to create our new graph, all we have to do is take the graph they provided us, click it, grab it, and move it right 1 and up 4. And in Alex, that's what you'll do. But when you make your graph with paper and pencil, that means you're going to have to adjust your coordinates. So let's go ahead and note how we'll adjust our coordinates. Right 1. Well, let's say you're here and you move right 1. The x's are adding 1. So this would be x's add 1. All right. Up 4. Let's say you're here and you go up 4. Well, then the y's are increasing. The y's are adding. So this would be y's add 4. So if you want to get your new table of points, all you have to do is take your table of points from your parent graph, and specifically with the x's, add 1. And that will give you your new x values. When it comes to the y values, you're going to take the y values from your parent graph, and you're going to add 4. And that will give you your new y values. All right, so this is very easy to do, so let's do it. Let's start with the x's, and let's start at the bottom. 2 add 1 is 3. 1 add 1 is 2. 0 add 1 is 1. Negative 1 add 1 is 0. Negative 2 add 1 is negative 1. Okay, y's we're going to add 4. 9 add 4 is 13. 3 add 4 is 7. 1 add 4 is 5. 1/3 add 4 is 4 1/3, also known as 13/3, which is approximately 4.3 repeating. Actually, it's exactly 4.3 repeating. And then 1/9 plus 4 would be 4 1/9. Let's see, 9 times 4, 36 plus 1, that's 37/9. And that would be 4.1 repeating. Okay, so now we can plot these new points on our graph. Let's go ahead and do that here. All right, let's do the easy ones first. 3, 13. So starting at the origin, 1, 2, 3 to the right, and then up 13 would put us here. All right, 2, 7 would be here. 1, 5 would be here. 0, 4.3 would be here. -1, 4.1 repeating would be here. And when we connect the dots, we get the transformed graph . All right, how about that asymptote? What's going to happen to the asymptote? Well, our asymptote is a horizontal asymptote, so it looks like this. And what happens when you take a horizontal asymptote and you move it to the right? Nothing. Still in the same place. When you move a horizontal left or right, nothing changes. It's still in the same place. But what happens when you move it up? Will that change it? Yes. So if you start here and you go up, 1, 2, 3, 4, now you're 4 steps higher than what you were before. So instead of being down here at a height of 0, we move up to a height of 4. So our asymptote is going to be at 4. Okay, notice that you can also see this happening in the y values. As we go up the chart, we're getting smaller and smaller, but closer and closer to 4, and we'll never reach it. 13, 7, 5, 4.3 repeating, 4.1 repeating, and so on, getting closer and closer and closer to, but never reaching 4.